dear students. Welcome back to the Part 2 of ICSE Class 10 Chemistry, that is your chemical bonding. See, such an interesting chapter, chemical bonding. That is, chemical bonding is like bonding between a teacher and students like you. That is why we again met with another interesting session of chemical bonding. Okay. Before going into the video, I will just tell you two important points. Okay. Imagine you are in your classroom. What is the time period of what is the time of one period? It's like 40 minutes. For example, you are sitting in your chemistry period. So how long will be that period? That is for 40 minutes. Imagine your chemistry ma'am is teaching you chemical bonding and she has started teaching that about chemical bonding. Then after 10 minutes bell rang. And what will be the mindset of students? Students, you will be deeply involved in thinking about chemical bonding. By the time you are deeply involved in chemical bonding, bell rang and teacher is going off. Will you remember that something about chemical bonding? Definitely not. That is what is happening between you and me. If I just stop the videos with just 10 minutes about what I am trying to teach about your science subjects, there will be discontinuity between you and me. Am I clear? Yes. So, I am just taking all my videos for the duration of one period. That is, in your school, your one period is for 40 minutes or 45 minutes. That is why to have that continuity, I am just taking videos. I am just connected with you for 40 minutes. So, to just keep you engaged with only chemical bonding for 40 minutes. Yes? So, without further delay, let's go to our today's topic. Welcome back, my dear students, for the today's topic, that is your chemical bonding. In that we have already discussed about electrovalent bond or ionic bond in my previous video. Okay, so I already said before starting my lesson or today's class, I said imagine you are sitting inside a chemistry class. I am your chemistry teacher. So the bell started. Okay, the period started and the bell rang also. Now it is chemistry period. So this period will extend for 40 minutes or 35 minutes. Hope so. If you cooperate now, then the period will get over by 35 or 40 minutes. Okay then. So before starting, I just wanted to tell you, see, in a class, I am imagining that you are sitting in front of me. Okay, so I think 30 to 40 students are waiting to listen for chemical bonding. I am the teacher who is going to start my teaching. What do I need? I want response from students. You also, for what students are waiting to listen for the lecture, isn't it? So that's a reciprocal process, a bonding between you and me. If at all we need a bonding between us, definitely there should be mutual understanding. Yes, then only mutual sharing of electrons only will form bonds between two elements. And here also, as I said, we are forming a bond now. That is a teacher, your chemistry teacher, me, and my students who wanted to listen for chemistry class of chemical bonding. Okay, so what is being shared? According to me, what has to be shared? You are listening to my class and what do I need from you? I definitely need like, comment and subscribe and watch my videos. Hope you all understood, my dear children. My students are really very brilliant. I know that. Okay, so for a teacher, you are going to definitely, whatever I have taught, students, how will I know that students have understood whatever I have taught today? At the end of the period, teacher will ask, students, did you all understand today's class? Students will stand up and say that they understood today's class. or they have so and so doubts. They will stand up and ask doubts. But unfortunately, students, you are not in front of me. I cannot see you. But you are in front of your phone, your mobile. So what are you going to do now? If you have any doubts, children, in today's class, please don't forget to send your doubts in the comment section. And if you really understood, okay, you that also, please comment in the comment section. Don't be the silent spectators, my dear children. See, as a teacher, I expect whether you understood the topic or you want any more clarity, you want any more explanation, whatever it is, it's of course student's part. Okay, you are boss for me. Okay, whatever you say, I will always obey for your command. So, please, my dear students, please tell your opinion. If you have understood today's topic, say that, ma'am, we very clearly understood. Okay, at least 300 or 400 students are watching my videos, chemical bonding videos, my previous video, isn't it? But how do I know that whether you understood or not? I have to know whether you understood or not. If you have any doubts, please feel free to ask me in the comment section. I will definitely answer for each and every doubts of yours. Okay? Okay, let's begin our today's topic. So today's topic is covalent bond and coordinate bond. We have already seen ionic bond. Okay, what is ionic bond? Formation of ions. Okay, one atom is giving electron and another atom is gaining or getting electron. So, one who is giving is getting plus charge and one who is receiving is getting minus charge. So, the bond formed between them is ionic bond. So, that part is over in my previous video. Don't worry, my dear children, those who are new for this channel, I will post the link in the description box of chemical bonding part 1. Okay, you can refer to part 1. Okay, now today's topic is covalent bond. What is covalent bond? Co means joint. Coordination. We will normally say na coordination. What is that? Co means two of them join together to do some work. Okay, what are they joining for? They are joining to share their valency. What is valency? The number of outermost electrons or valence electrons is its valency. Covalent bond. So, to form a bond, they need to share its valency. What is there in the valency? Electrons. So, what is covalent bond? Sharing, mutual sharing. Mutual means both of them are not getting affected. One is, in ionic bond, if you see, one is losing electron, one is gaining electron. But here, covalent bond, both of the atoms are not losing anything, but they are mutually sharing. They both are in wonderful understanding between them. Okay, if you give me one chocolate, another day I will give you back one more chocolate. Okay, that's mutual understanding between two kids like you all. Okay, now the two atoms, if they are in mutual understanding, that is they mutually share the number of electrons and form a bond which is called as covalent bond. Okay, let's see the definition. Covalent bond, mutual sharing of one or more pair of electrons. Electrons don't come in a single way. It needs a pair to form a bond. See, if I have written a bond like this, it means it has two electrons. Okay, a bond is made up by two electrons. Okay, so that is why I have mentioned one or more pair of electrons. And the compound formed, what is the resultant compound formed? We call that as covalent compound or covalent molecule. Okay, now there's one more. When non-metal combines with another non-metal, You all understood. Like in my periodic table chapter, I have told you metals, that is group 1A element, 2A elements are all metals. 1A elements are called as alkali metals and 2A elements are called as alkaline metals. Okay, they are all metals. And coming to 3A, 4A, 5A, all are, or almost majority of them are non-metals. Okay, so when non-metal combines with another non-metal, the sharing of electrons takes place. See, both of them are birds of same feathers. Non-metal is a bird of same color feather. Another non-metal is the bird of same color feather. Okay, both requires one electron. For example, I am telling, both requires one electron. So what happens? Okay, as I said, chocolate example. Today, this boy is giving 5-star to another boy. That boy is giving dairy milk to another boy. Okay, both of them are eating 2 chocolates. Yes, likewise the same thing is happening here. Okay, non-metal always requires electrons. From where it is getting? It is getting from another non-metal. It is not, my dear children, don't get confused. Non-metal can also react with metal also. But here for an example, I am telling you, when non-metal combines with another non-metal, it forms a bond by mutual sharing of electrons, which you call it as covalent bond. Takes place and covalent bond is formed. For an example, if you see, hydrogen is a non-metal, chlorine is another non-metal. Hydrogen and chlorine. See, hydrogen is always plus. It has 1 electron. Hydrogen atomic number is 1 and it has 1 electron in its outermost valence shell. Then chlorine, if you see, in its valence shell it has 7 electrons. So, these 3 are in pairs. No need to disturb them. One is left without any pair. So what? It needs 1 more electron. So that 1 electron hydrogen is giving, and hydrogen needs 1 more electron because it is also left without pair. So that hydrogen it gets from chlorine and forms, see, I have denoted with green. See, 1x from hydrogen and chlorine, 1 unpaired electron forms a bond. So this type of bonding is called as covalent bonding. Okay, so this is about the introduction of covalent bonding. Next, covalent bond can be of 3 types. Covalent bond can be of 3 types. Number 1, single bond or single covalent bond, double covalent bond or double bonds, triple covalent bond or triple bonds. Okay, what is single covalent bond? Sharing of only 1 pair of electrons between 2 atoms is called, and it forms single covalent bond. It is denoted by just a very short line between 2 atoms. Example, hydrogen to hydrogen, single bond. Chlorine to chlorine, single bond. Hydrogen and chlorine, single bond. Okay, this is about single bond. Next, double bond, sharing of 2 pairs of electrons between the 2 atoms. It is denoted by 2 single lines, 2 lines. Okay, so that is double bond. Example, see, carbon is forming double bond with 1 oxygen, and it is also forming, because carbon's valency is 4. Okay, carbon is tetravalent, so it has 4 electrons. With its 1 electron and oxygen also 1 more electron, it forms bond. And as I said, with the second electron, oxygen shares. Oxygen also has here, so it forms a bond. And with the third electron, with 1 more oxygen, it forms bond. And with the 4th electron, it forms 1 more bond. So 2 double bonds for carbon dioxide molecule. Then, see, look at this structure. Carbon has 4 electrons, valence electrons, and oxygen also has 1, 2, 3, 4, 5, 6. Yes, 1, 2, 3, 4, 5, 6. So this shares and forms double bond, double bond. This is double bond. Next, triple bond. Triple bond means sharing of 3 pairs of electrons and forms 3 single bonds. It's called as triple bond. Take the very good example for triple bond is nitrogen. Nitrogen. Homo, like what do you say? They both are same atom. So nitrogen and nitrogen form triple bond between them. Then this is ethine. That is alkyne. If you see carbon, I said carbon valency is 4. So only one bond it is forming with hydrogen and another 3 bonds it is forming with carbon only. So triple bond example is ethine and nitrogen. Whereas double bond it is carbon dioxide. Single bond it is hydrogen molecule, chlorine molecule or hydrogen chloride. Okay, this is what is the introduction for covalent bond and its types. Welcome back my dear students. Next topic is non-polar covalent compounds and polar covalent compounds. What are non-polar covalent compounds? Polar, the word polar means in chemistry different charges. Polarization means production of plus and minus charge. Polarity means plus and minus. Okay, non-polar covalent compounds means the compounds do not get plus and minus charge. They are neutral. They don't have plus, they don't have minus. Which means when will an atom gets plus and minus charge? When it has more electrons and when it has less electrons. Isn't it? The less electrons will try to get electron from the less number of the less electron atom wants to get one of the electron from other atom which has more electron, that is plus, isn't it? So that is polarity, polar compounds. But here non-polar, they do not have plus and minus, both have equal number of electrons, don't want to look electrons from the other atoms, so they are neutral. So let's see the definition. The covalent compounds are called as non-polar when shared pair of electrons are equally distributed. Both of them have equal number of electrons. Nobody is having very high, nobody is having low. Both of them have equal number of electrons. So no charge separation takes place. No charge is being generated. Charge in the sense one atom who is giving electron gets plus, one atom who is receiving electrons gets minus. Like that, no charge separation because equal number of electrons are distributed. Both of them has equal number of electrons. They are electrically neutral. Next, for example, if you see hydrogen, HH molecule both has one electron. So this one electron together forms a single bond between them. Chlorine has equal number of electrons. Oxygen molecule are perfectly non-polar molecules. Next, they do not ionize in water. Ionize in the sense gets separation of charges. They don't get separated as plus and minus in water when dissolved in water. Okay, so due to lack of charge separation, so they are called as non-polar covalent compounds. Next, polar covalent compounds. The covalent compounds are said to be polar when shared pair of electrons. The shared pair of electrons are not equally distributed. One of the atom gets more, one of the atom gets less. They are not equally distributed. So when they are not getting equally distributed, they will have fractional positive charge and fractional negative charge. Fractional in the sense it is partial positive, partial negative. They both will have fractional positive and negative charge, which means they have partial positive and partial negative charge, which is highly unstable only. That is not stable for throughout the period. They will again become non-polar molecule only. Okay, so that is fractional positive and fractional negative charge. Okay, so when they are in fractional positive and negative charge, they ionize easily in water because they have polarity. They have charges plus and minus. For example, HCl molecule. HCl divides as H plus and Cl minus. So they are polar molecules. H carries fractional positive charge, Cl carries fractional negative charge. Next, H2O molecule, H plus and OH minus. H plus is fractional positive charge and OH minus is fractional negative charge. So they are called as polar covalent molecules, mutual sharing of electrons. Okay. Next, one more important definition called ionization. The process by which covalent compounds are converted to ionic compounds. See here I am telling the covalent molecules are becoming polar. They are getting converted to fractional positive and fractional negative. So when in such process the covalent molecules or compounds are converted to ionic compounds, they are called, or that process is called as ionization. When the covalent molecules, covalent itself is mutual sharing, electrically neutral, both are electrically neutral, but in some case H plus and Cl minus, H needs to donate one electron to Cl minus. In such case they are raising up polarity, which you call that process as ionization. You are raising up ions, plus and minus ions. So the process of converting covalent compounds into ionic compounds are called as ionization. Next is conditions for the formation of covalent bond. Let's see what are the conditions. Number 1, both the atoms should have 4 or more electrons in its valence shell. Okay, it should have more than 4 electrons to form a covalent compound. But exceptions are hydrogen, which has only 1 electron, beryllium, which has hydrogen, helium, lithium, beryllium. Beryllium has 2 electrons. Boron, aluminium has 3 electrons. So exceptions are these 3. Remaining all will have probably 4 electrons to form a covalent bond. Next, second condition is both should have very high electronegativity. Both should have, because both are non-metal only. So when both are non-metals, for example I am telling, will have definitely high electronegativity. So electronegativity is tendency to get an electron. So both the atoms, if it has very high electronegativity, both will share its electron, mutually share its electron. So electronegativity. Next, both the atoms should have high electron affinity. Affinity means electron attracting power. Okay, so both the atoms should definitely have electron attracting power, strong force of attraction to pull that electron, leftover electron towards itself. So that is high electron affinity. Next, both the atoms should have high ionization energy also. The energy required to produce the partial positive and partial negative charge, ions, are called as ionization energy. Okay, so both the atoms should have high ionization energy. So these are the conditions for the formation of covalent bond. Okay, so let me tell you 2 examples for formation of molecule. That is, both are same atoms. When both atoms are same, likewise we have chlorine and nitrogen. So I am going to tell you the example of chlorine and nitrogen. First let me start with chlorine, formation of chlorine molecule. How chlorine molecule is formed from chlorine atom. If you see, the electronic configuration of chlorine is 17. That is 1s2, 2s2, 2p6. That is, this is 2, 8 and here 7. It needs 1 electron to attain its nearest noble gas configuration, that is argon. 2, 8 and 8. 8, if you see, it satisfies its octet rule. So it needs 1 electron to satisfy the octet rule. To attain stable electronic configuration, it needs 1 electron. So it forms single covalent bond. It needs only 1 electron. So it forms a covalent bond with another chlorine atom. Because both chlorine atoms requires 1 electron only. So that 1 electron which is left unpaired forms a single covalent bond. Okay, let's see before combination, before combining of 2 chlorine atoms. Chlorine atom. If you see, it has 7, outermost it has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Same way for the another chlorine atom, it has 1, 2, 3, 4, 5, 6 and one leftover unpaired electron. So to note down the difference between this chlorine atom and this chlorine atom, I have denoted it with dot and this one as cross. Okay, now this both are combining due to high electron affinity and high electronegativity also. So what is happening? This cross and this one is forming a single covalent bond, and thus it forms single covalent bond between chlorine atom and forms chlorine molecule. Okay, so hope you understood. Okay, this is the formation of chlorine molecule. Next we will see formation of nitrogen. Nitrogen and nitrogen. How is it forming triple bond between them? Next is formation of nitrogen molecule. How nitrogen atom and nitrogen atom is forming a molecule and what type of bond is it forming? Let's see. Nitrogen's electronic configuration is 7. So 1s2, 2s2, 2p5. So outermost it has 7 valence electrons. So it is 7. So the nearest noble gas is neon, which carries atomic number 10. That is, it needs 3 electrons to attain its stable electronic configuration. It needs 3 electrons. Okay, so to attain stable electronic configuration, nitrogen needs 3 electrons. So before combination, after combination. So before combination, if you see nitrogen, see 5 valence electrons. So 2 and 3. For this nitrogen, 2 is paired and 3 is unpaired. So this 2, as I said, it needs 3 electrons to form its to attain its stable electronic configuration. So this electron of nitrogen atom and this electron of nitrogen atom form a single bond. This electron forms single bond. This electron and this electron forms a single bond. So totally how many bonds it is forming? It is forming triple bond. So between nitrogen and nitrogen it forms triple bond and forms nitrogen molecule. So it forms triple covalent bond. So this is how they form bonds. Next, this I said 2 examples of a molecule, same atoms when they are joined, but here it forms different atoms. How will a molecule is formed when 2 different atoms are combining? See, let me tell you carbon tetrachloride as an example. So before combination, after combination. So we know that carbon has 4 tetravalency, that is it has 4 valence electrons in its outermost shell. See, carbon has 4 valence electrons in its outermost shell and chlorine needs 1 electron to attain its stable electronic configuration. See, carbon 1, 2, 3, 4 and it reacts with 4 chlorine atoms where chlorine requires only 1, remaining all are paired. So this one leftover unpaired electron of chlorine reacts with or forms a bond with 1 electron of carbon. So this chlorine 1 electron forms a bond with another electron of carbon. Then this one, then this one. So totally how many bonds it is making? 4 single covalent bonds. So carbon forming single covalent bond, this carbon forming single covalent bond and this carbon forming single covalent bond and this carbon forming single covalent bond. So 4 single covalent bonds are formed between carbon and chloride. So it is called as carbon tetrachloride. Okay. Now next example is water molecule. When hydrogen and oxygen is reacting, what type of bonds are? Covalent bonds are formed. Let's see. Before combination, after combination. We know that hydrogen has only 1 electron in its valence shell, but oxygen has 6 electrons. In it 2 are paired and 1 here unpaired, here it is unpaired. So this unpaired electron combines with another unpaired electron of hydrogen and another. So it has 1 more unpaired electron electron, no? So that will be combined with 1 electron of hydrogen. So totally how many bonds it is making? 2 covalent bonds it is making. See, 2 covalent bonds. So 2 single covalent bonds are being made for water molecule. Okay, okay children? Okay, so this is what is covalent compounds. That's all for the class today. As I said, I will end up this session as how you are sitting in a class. Class ends by 35 minutes, isn't it? I hope, I didn't note down the time, but still I hope that I am ending up this session by 35 minutes only. Okay, so before ending my session, I will again remind you to don't forget to, before starting to watch this lecture, please click like button. Don't forget to drop a comment in the comment section that whether you understood or not, you want any more clarification. If you have any doubts or any other chapter you want next after this chemical bonding, you need any chapter which you don't understand properly, please give suggestions in the comment section. Okay, I hope for this video I definitely get comments from students because we are in the classroom. I hope I am very excited to see the comments from you all. Okay, this video I am expecting comments and like button. Then don't forget to click like and then subscribe and watch my videos, my dear children. Okay, so we'll meet in the next another very short session in which we will discuss about the comparison between the properties of electrovalent bond and covalent bond, and then we are left up with one more bond called as coordinate bond. Okay, so hope we will meet in the next day with another period. Okay, so this is your chemistry teacher signing off for today, and don't forget whatever I told you. Okay, see you all in the next session. Thank you.